We have advanced artificial intelligence that can map crop diseases down to the square centimeter, an autonomous multi-rotor aircraft capable of hauling massive payloads over rugged terrain. But getting that aerospace technology onto an isolated 2-acre farm in rural India is an immense logistical bottleneck. Historically, the digital divide is steepest here. The local economy relies heavily on manual agricultural labor, and the high-tech, high-yield opportunities remain concentrated in urban centers, leaving rural communities, and specifically rural women, entirely disconnected from the modern aerospace sector. To solve this deployment problem, the HAL Didis initiative trains these local women to become the human bridge. They learn to pilot commercial-grade UAVs, manage digital farming data, and run agricultural operations right in their own districts. But a pilot needs a base of operations. That physical solution is the Meghdev Drone Station. This is a fully autonomous 1-acre airport for drones. It is designed to be dropped directly at the panchayat, or village, level. Scaling aerospace technology across thousands of remote districts requires rugged, off-grid infrastructure. Packaging the entire operation into modular, solar-powered shipping containers bypasses the lack of traditional brick-and-mortar facilities and gets these hubs online immediately. Inside the container, the ecosystem begins with a simulation lab. Here, local trainees log the precise digital flight hours required to earn their commercial pilot licenses before they ever touch a physical aircraft. Next to the lab is the administrative desk, which functions as a hardware rental hub. Farmers lease a heavy-duty drone for a single spraying session or an entire season, avoiding the massive capital investment required to purchase these machines outright. The entire rental and logistics process is organized through this mobile interface, the HAL app. A farmer logs in, selects the drone seva, or farming nodes, and instantly books a local pilot and hardware for their specific acreage. As these orders process, the container's onboard servers continuously sync with a national command center, feeding real-time operational data from the village level back to the main grid. Operating commercial UAVs over dusty, high-heat agricultural environments causes intense physical wear. To prevent equipment failures, the station houses a dedicated repair bay. Local operators perform highly technical electronic PCB diagnostics, calibrations, and component replacements directly on site. Meanwhile, the charging bays manage the complex thermal loads of high-capacity lithium polymer batteries, ensuring a constant rotation of power for daily flight operations. By integrating sales, rental, training, repair, and flight operations under one roof, the station eliminates the weeks-long logistical delays that typically stall rural technology rollouts. With a fresh battery and a confirmed flight plan, the multi-rotor drone spins up and launches directly from the container's reinforced roof helipod. These specific airframes carry a massive payload of up to 70 liters. That capacity translates directly into speed, allowing a single operator to cover dozens of acres in a fraction of the time it takes a ground crew. The system utilizes precision nozzle architecture to atomize the chemicals. This ensures complete crop coverage while mathematically reducing overspray and chemical waste compared to traditional, less targeted tractor methods. To guarantee uniform coverage, the drone follows an automated grid flight path, maintaining centimeter-level accuracy. While spraying, it simultaneously captures multispectral data. It reads biochemical signals from the field, flagging exact zones of poor crop health or pest infestation in real time. Performing the chemical application and the survey at the same time provides a high-resolution map of field conditions alongside the physical spray run. The drone returns to the container pad for a quick battery swap. Inside, the operator and the local farmer review the newly captured crop intelligence together to plan their next targeted intervention. This hyper-local cycle is the foundation of a massive national mandate known as One Village, One Drone, designed to standardize precision agriculture across the country. To financially underwrite this hardware distribution, a layered stack of government subsidies absorbs the upfront capital costs for local agricultural cooperatives. Building momentum, the Meghdev network operations aim to hit a specific, massive scale, deploying 11,000 drones across 831 districts. Sophisticated drones in the sky only function when they are supported by rugged, female-led infrastructure anchored firmly on the ground.